Here, um, this material, if you want to use the material I send you, it starts with an overview. Like it gives a full overview, then it starts step by step. Here, var my variable equals 42. Then my variable equals 50. Let my constant equals 42. In Swift, you don't need to tell what's the type. Like it's not like Java. We have to tell this is integer, this is string, this is double. No, it's enough just to put the word var. Var means you are creating a variable. The value of the variable will let the compiler knows what type the variable is. Yes, Vivek, you have a question? Yeah. Let here means we are not dealing with variable, it's constant. The difference between constant and variable, constant has a fixed value which cannot be changed. So my variable here, the example here is showing you how you have a value for the variable and then you change the value, which is acceptable. But when it's let, it means this is a constant. The constant value cannot be changed. And if you try to change it, it's gonna be wrong. Like here, let implicit integer equals 7. Let implicit double equals 7.0. Let explicit double equals 7. Yes, user defined. Here, when you put only 70, so that the compiler will understand this is integer. If you want it to be double, you have to put 70.0, or you have to use colon double. So here in this case, even if you give it as only 70 without point O, the compiler will still understand this is double because you have written it completely. Which means we can, in Swift, leave it for the compiler to determine what type of variable or constant is it, or we can use colon and the type. Both are okay. Let label equals the width is, so the compiler will understand label is string. Let width equals 94. The compiler will understand width is integer. Let width label equals label plus string width. Here, width is what? Is integer. Label is string. In Swift, you can't merge using plus string with integer. So string here actually is converting. So it converts 94 to string, then merge it with the label. Look at this example. Now, let apples equal 3. Apples is integer. Let oranges equals 5. Oranges is integer. Let apple summary equals quotation. Quotation means it's string. I have slash and between parentheses the word apples, then apples. Anytime you have a string and you want to merge value within the string, you can put slash and the variable name or the constant name between parentheses. Let's try this here in our compiler. Run. Oh, okay. Sorry, I didn't notice. I copied the lines numbers. Okay, let's run again. I don't have any printing. So here, print what? Apple summary. Look here, I have 3 apples. So apple summary, I have then the number of apples, then apples. Let's print fruit summary, not apple summary. What does it say? I have 8 pieces of fruit. 8 pieces. I have, look here, apples plus oranges and pieces. So because they are between parentheses, the compiler understand these are values. So apples 3, oranges 5, the result of the plus operation is 8, so that's it. Even if you want to print, you can use it. Like, let me show you. Forget about apple summary and the fruit summary. Suppose I don't have them and I want to print. Print I have slash, let's say, oranges. Pieces of oranges. I have 5 pieces of oranges. So it's the same. If you are creating a variable which is a string, you can merge the value within the string. Or you can merge the value within the printing of string. What is the definition of slash? It's not slash, it's together. Slash with parentheses, it means you have to put here the value. Suppose let student name equals Sangeeta. Then print we have a student, her name is, I have to put it between quotation. How can I put the name? I have to use slash and between parentheses student name. We have a student, her name is, I didn't put space after is, now I put space, so which means what you have here is a value, regardless about is the value integer, double, string, or whatever. No, the constant cannot be changed. Let me show you. After I print everything, apples equal 7. Print we have slash apples apples. I want to print we have how many number of apples. Run. Cannot assign to value apples is a let constant apples equal 7. Look here, Swift, what does it say? Change let to var to make it mutable. This is the suggestion. Okay, I'll make it var. Now run. We have 7 apples. When it's let, it was wrong. When I changed it to var, it's working. So you can see the value of any attribute, I'm not gonna say any variable because it's not a variable. Any property, every one of these we can call it property. The value of any property, if the property we use let, then the property is constant. Its value cannot be changed. If you want to change the value, don't use let. It's easy. Just use var. No, it doesn't have semicolon unless you want to write two statements in the same line. Like here, semicolon is okay. But in different lines, because for Swift, enter enter is considered as end of the line, so it's okay. Enter or semicolon. It means the end of the statement. So the statement is end by semicolon or end by enter. Yes, it is. So here, apple with capital A is not recognized. Unresolved identifier apples. Look here, by the way, guys, as I told you, this is an overview. We will come back to talk about these things in details. Like here, we are dealing with what? This is an array. Creates an array. How to create an array? Var shopping list equals catfish words hubbles blue paint. Shopping's list of 1 equals bottle of water. So it changes. It changes the value. Var occupations equals Malcolm captain. This is something we call it dictionary. Here, this example is showing us the normal array and the dictionary. The normal array, the reference for each item is the index. Like catfish is index 0, water index 1, tuples index 2, and so on. But if we define or if we create a dictionary, then the reference for the value is the key. For the dictionary, each item in the dictionary is consisting of 2 parts: key, value, key, value. We can add more: key, value, key, value. And the reference for the value is not index, it's the key. And here is the list. Let empty array. This is an empty array and this is the list. This is an empty array. In Swift, arrays are different than in Java. In Swift, arrays are dynamic. Yes, key must be unique. That's a good remark, Rahul. We will get back to dictionary and full details. But you should know the arrays in Swift are dynamic, not like in Java. Look at this example. Let individual score. This is an array. Var team score 0 for score in individual scores. And one more thing about Swift you should know, which is different than Java. In Java, we don't have to use brackets if we have one statement. If you still remember, I told you when we have for or if, then if it's only one statement, no need to use brackets. You have to use brackets when it's block of statements. In Swift, you must, even if it's one. So in Swift, you have to use brackets with for and with if, with else, regardless about how many statements you have. And in Swift, look at this space between the variable and plus. It's a must. If you don't leave space, it's wrong. Let me show you. Run. We don't have any printing, so it doesn't show anything. But here it means we don't have any errors. Look here, if I forgot to put space, directly it gives me error. The space is important. How about here? Like in Java, we don't put spaces. Okay, no problem. Here, no problem. And as you see, we don't have to put parentheses when we use if. In Java, you must. So if you put or not is okay in Swift. It doesn't work, Elmi. You need a space. You mean here? Yes, here is okay. No, it's not okay. You must put space. Yeah. As you see, we can print just by writing the name of the array, which is not available in Java. You mean like this? Okay. If we remove both spaces from both sides. If we print team score, it's 11. Even here, var team score equals. Without space, we get error. If you remove spaces from both sides, what? Stop. Run. Your program is already running. Please stop it. Okay, stop. Okay, so no problem here. How the team score is 11. If score is 0. If score greater than 50, score plus 3. Else, score plus 1. We have 4. For what? For score and individual scores, which means score is 75. Is it greater than 50? Yes. So team scores is 3. Don't go to else, go back to 4. Now don't forget the team score is 3. Go to 34. 34 greater than 50? No. So we add 1. It becomes 4. 103. You have to add 3. It becomes 7. 87. You have to add 3. It's 10. Go back. 12. You have to add 1. So it's 11. Yes, Sangita. What do you mean by differently? Use print and if? Yes, you can. Yes. You mean here? So it shows us how the team scores was growing from 3 to 4 to 7 to 10 to 11, and finally it's 11. Okay, this is something very critical in Swift, which is not in other languages. Optional. Optional. Optional means the type is not determined yet. So when we use the question mark, it's like possibly. So what I have here is maybe string. If I don't use question mark, then I'm sure it's a string. If I use the question mark, then I'm not sure. Maybe it's a string, maybe not. Optional string equals nil. We use in Swift not null, it's nil. Optional name string John pleased. Okay. Greeting hello. If let name equals optional name, greeting equals hello name. It's confusing. How come we have if let This is something weird, but this is in Swift. So let's understand. If let name equals optional name, what is the optional name? Optional name is John pleased. Here it's like let name equals optional name. If it works and we can put this value here, then greeting equals hello. The idea here is to prevent the type mismatch. To prevent the type mismatch. Let's try to do it here. Var n integer okay. Is it integer or not? We are not sure. Maybe it will be integer, maybe not. So if let n equals 7.5, print it's double. I always forget this. Okay. Look here. Initializer for conditional binding must have optional type, not double. Optional type. I here ask if let n equals 7.5. So here I in the if here I'm sure about the value is double, but the value is optional. We are not sure about it, so I can't use if let n equals this value. That's why it gives me an error. It's optional. Optional optional means we are not sure about the type. Like here is optional, but the optional name, if name equals optional name. Optional name, we already define it as optional with using the question mark. When you use if let, then you are not sure about what is the value. Here, the value is double. I'm sure it's double. That's why there is a ring. If I want to try it, I can here put var, let's say m double optional double. Then here, okay, let me say equals 7.5. if n equals m, double, it has to be capital, sorry. Look here, what does it say? It's double. Um, this is not error, this is warning. Forget about the warning. The value at the end, it's double. How come integer is double? When we use iflet, Elmi, when we use iflet, we don't put double equal. It's because it's not comparing two values if they are equal. It's it's not comparing if they are equal. It compares if we can put this value here. I'm not trying to check if the value of n equals m. No. I'm trying to check if I can give n the value of m. Do you understand what I mean? Okay. So if I can give n the value of m, then it's double. Let me show you if we are sure about the types. Here, n is integer, not optional. M is double, not optional. It gives us an error. Because using iflet means you are not sure about the type of and the value of what you are trying to give. So here I should not use iflet n equals m because I know n will never equals m because n is integer, m is double, and they have different values. I still have an error because it's not about the value. Here is 7 and here is 7. But using let n equals m and if let with two variables which are final type is not correct. Look here. If let n equals m, it works. Why we are using, okay, I'll show you why. Instead of printing its double, I'll print the value of m as Look here. N is integer equals 7. M is optional double. If let n equals m, print n. What does it mean here? It means if I can, if here, if let, it means if I can give n the value of m. If it works, then print n. And as you see here, n is what? 7.7. Yes. Now, if this is not optional, I have an error. Guys, by the way, we use iflet with a different example. We don't use it with a clear value like here. We often use iflet when we ask the user to enter a value. Like we want the user to enter a value, but we are not sure if the user will enter a correct type. So we make it optional. Or if we are having an arithmetic operation and we are not sure about the result will be double or integer. Mm, so we use optional. Even if if we don't have this feature, which is the optional, and you are making calculations, and you are not sure if the result will be integer or double, you have to use double because double is containing double and integer. But when we read from the keyboard and we ask the user to enter a number, what if the user enters a string? If we are using Java, this will cause an exception. If in Java and you ask the user to enter a value which is a number like an integer or double, but the user enters letters, what will happen? It will crash. Here in Swift, it will not crash. Why? Because it checks if this can take the value of that. If yes is okay, if not, then forget about it. Do something else. I'll show you what I mean. Let's just... Here is using of switch. You know what does it mean, switch? Here, let me show you. N is a string. M is maybe double. If n equal m, print the value of n. Now let's do the opposite. So here n is double, maybe double, and m is maybe string. Can n have the value of m? Yes, okay. N is maybe double, m is maybe string, and here we have string, or we have A, B, C, D, E, F, G, whatever. If I remove the optional here, run. It depends, because here I didn't give any value for n. I just said n is double. Guys, how a string can be compared to double. It's not comparison. It's not comparison. If n can get the value of m, anyways, guys, I don't want to waste a lot of time here. This is just an overview. We will have a section called optional values. We will talk more about optional. Okay, so let's go on. We will get back to the optional and the idea of optional. Here is using of switch. This example is about switch. Let vegetable equals red pepper. Switch vegetable. Case celery, do this. Case cucumber or watercress, do this. case let x, where x dot has suffix pepper, let vegetable equals, is it spicy? Then default, let vegetable comment equals everything tastes good in soup. So here, this example is trying to show us the options, the different options of using switch. Let's take this and try to print it out to see the results. Forget about warnings. Finally, I want to print vegetable comment. We have an error. What's the error? Oh, okay. Here, as you see, vegetable comment is defined inside the switch. That's why it doesn't find it. So we should print inside the switch. Okay, it doesn't work. So let me return it back outside, but I have to define it here, but not let, because let means it cannot be changed. So var vegetable comment equals nil, and first remove let here, remove let here, remove let here, and remove. Okay, without we need to give a type. String. I'm sleepy. String. String. Okay. So finally it brands. It is a spicy red pepper. So if we go through switch, case means if it matches. So if vegetable here matches celery, then we do this. Case cucumber, if it matches cucumber, then it has to be that would make a good tea. If it's not cucumber, so maybe it's this one, water cress. If it's not this or this, then go to the other one. Case let x where x dot has suffix. I think you can then understand from the context what does it mean has suffix pepper. Suffix, which means the second part. So it has suffix pepper, vegetable, it is spicy, and X. What is X? X anything where X has suffix pepper. So X will be red pepper. So it is a spicy X. What exactly the tutorial here trying to tell you about Swift? It tries to show you how Swift is flexible. Swift is one of flexible languages. We have we can actually do some things unusual. We can do some things we don't often do with classical languages. Like we cannot do this in Java, we cannot do this in C++, but we can do it in Swift. It makes you search inside the variable which we are trying to find its value. Let's look at this example. Interesting numbers. Prime 2, 3, 5, 7. These are prime numbers. Fibonacci series starts with 1, 1, 2, 3, 5, 8. After 8, we have what? After 8, we have 13. You know the rule of Fibonacci or not? 5 plus 8, 13. 13 plus 8, 21, and so on. Squares, here we have squares 1, 4, 9, 16, and 25. Okay, so we understand what are these. Look here, I don't have three arrays. It's not three arrays, it's one array, starting here and ends here. One array has three arrays inside it. Var largest equals 0 for kind numbers and interesting numbers. Kind numbers. So for number n numbers, if number greater than largest, largest equals number. And finally, we have the largest. We can print out the largest. So what you can understand here for kind numbers n? What you can understand? Yes, so the key prime has these numbers. The key Fibonacci has these numbers. The key square has these numbers. So kind will be either prime, Fibonacci, or square. Numbers will be any of these numbers. So for number n numbers, it means I'm taking these numbers, which are 2, 3, 1, 1, 1. I'm taking them one by one and searching if any of them is greater than 0. Yes, I will find 2 will be greater than 0. But then when I go on, I will finally find 25 as the largest. So the dictionary here, as I told you, we can have a dictionary which is two parts, key and value. The example here trying to show you the dictionary can has two values. One of them is the key, but the other one is not single, it's array. Using while n less than 100. Okay, so this is how to use while. It's like Java. And using do while var m equals 2, do m equals m times 2, we and do then while m less than 8. It's the same concept. Now the for loop for I n 0 dot 3. You remember in Java, we have, if I want to do this, I have to write for I, integer I, equals 0, I less than or equal 3. So here, this is how to use for. For I n and the start, 2 dots, the end. For 1, 5, print for I n, print I. For I equals where for I n. Okay, so that's correct. What's the problem? For n for I n. Okay. What? Use of unresolved for I n 0 dot dot 3 for I n 1 dot dot 5. What's the problem here? For I n 1 to 5. I don't see any problem. How about spaces? No, there is no spaces. It has to be two dots, not three. It has to be two dots, not three, but um I'm not sure about which version this compiler is. There is sometimes we can find difference between versions. So you should make sure which version you are using. Anyways, you can use for like this way, or you can use it in the normal like in Java for var I equals I less I plus plus I or I plus plus, doesn't matter. It's up to you. You can use this or this. Functions and closures. I will leave this because it's a big topic. We will not go through it without explain it in full details. Objects and classes you already have here because closure is something new and you have to know it from the beginning. Object and the classes you already know what is the object, what is the class. So how to create class, it's the same like Java, class, shape. Here we don't have types, so variable and the attribute and its value. Function, symbol, description, its type is string. Yeah. Look here how to define the function. Function, which is method. In Java, we call it method. Here, we call it function. The function doesn't have a type here. We put the type here. So the name of the function, parentheses, maybe it has arguments or not, then you have to use like an arrow to put the return type, the type of the function, and it has return, so return is the same. Var shape equals shape. This is how you declare an object. Like here, this is the class. How to create object? This is how you create object. The name of the object equals the name of the class. Shape dot number of sides equals 7. Look at this example. Class named shape. Variable number of sides integer 0. Name string. Init here. Init, guys. What do you expect? What is init? What is init? Exactly. It's the constructor. So for the constructor, init, name, string, self. Self means what? Means this. So self.name equals name. And we have function, symbol description, string, return, blah, blah, blah. Okay. Another class square, and we have here what? Two dots, which is colon, named shape. What is this? What does it mean when we have a class, colon, another class? It means extends, inheritance. Exactly. Side length is double. So init is taking the side length and the name string. Self.sideLength equals side length. Super.init name number of sides equals 4. Function area returns double. Return side length times side length. Override function symbol description string. Here in Swift, when you want to override a function, it's not enough to write the function name. You have to write the word override. Override means you are overriding a function which is already exists in the parent. How to create an object from the square. Let test equals square with side length 5.2, name my test square. Look how we call the method. We have to write the argument dot colon, then its value. The argument name colon its value. Another example here. We will get back to classes with more details. Besides classes, we have in Swift enumeration and structures. Enumerations and structures are kind of structures similar to class, and we can create variables of the enum or of the structure. It's like how we create objects for the class. We will talk about this in full details later. Struct, you see here, struct card. It's like a class card, but it has different features. And enum, the name, case. So what is the enum? What is the struct? We will explain it. Protocols and extensions. For the classes, we can have protocols. Protocols for the classes are similar to getters and setters in Java. And we can use protocols and extensions for classes, for enum, for structures. Extension init exam protocol. So the protocol is something similar to the function. Now that's the overview, then we will start step by step from the beginning. Constants and variables, declaring constants and variables. This is how we do. How to put the type. Okay, guys, let me stop